Today topic is sedimentary structures. So as we know, the structures of sedimentary rocks that is used to refer to the interrelationship between the constituents grains which occurs in a group. Their deposition, it defines, it's called sedimentary structure, right? So sedimentary structures are important attributes of sedimentary rocks. So they occur on upper and lower surface of beds as well as within beds. So they can use to deduce the process and conditions of deposition, the directions of the currents which deposited that sediments. So now in this section, we will learn about the structures present in sedimentary rock that are both organic and inorganic in origin. Sedimentary structures are large-scale features which show variety of what is that interesting, right, variety of interesting and significant geometries that are produced by physical, chemical and biological processes operating on sediments during and after their deposition. So these sedimentary rocks exhibit a variety of structures which have depositional characters produced at the time of deposition of sedimentary rock, right? So now we are going to, important thing is the sedimentary primary structures, right? So now you see here, first one is bedding and second one is lamination and third one is cross bedding and graded bedding. And next one is sand dunes, ripple marks, rain prints or raindrops, mud cracks, and unconformities, right? So now the primary structures are formed during the deposition of the constituent sediments, physical or mechanical process operating during the deposition develop these structures like bedding and cross bedding or cross stratification and ripple marks, etc., etc. And therefore, they are also termed as mechanical structures also. So they are inorganic in nature, right? And also these primary structures are significant and may help us in determining paleocurrent conditions and rate of supply of sediments and mode of transportation and environment of deposition and also top and bottom of beds, right? So now we are going to one by one. First one is bedding. So what is the bedding and stratification? Now you see here. So we have read that clastic sedimentary rocks formed as a result of deposition of insoluble mechanically transported material that is in the form of bedded deposits and sheets and layers of various sizes, right? So these sedimentary rocks are generally layered rocks because of the deposition of similar or dissimilar in occur and grain size or mineral composition and sediments one over another in a basin. These individual layers of the sedimentary rock is called bed, right? Bed. So this bed thickness varies both vertically and laterally. So their organization upward increase or decrease in thickness reflect gradual change in depositional environment. So each of the bed is separated from the adjacent bed by developing a surface of contact which gives rise to a plane called bedding plane, right? Bedding plane. So, right. So they may be horizontal or inclined, right? So these beds may be thin of the order of few centimeters or maybe meters or even many meters thickness, right? So these parallel layers of different grain size or compositions are separated from each other by planes of weakness and indicate successive depositional surfaces that formed at the time of sedimentation. Okay. So you see, it is a planar arrangement of particles which can be easily distinguished by difference in color, composition, size, and also texture, right? So they may be only a few centimeters in thickness or maybe up to how much? Several meters. Okay. So they form in all sedimentary environments under which one? Under different conditions. So this bedding form by slow process. It's called suspension or by a rapid process such as during high flows or floods of rivers and seasons of strong wind, a desert, certain parts of the tide cycle in shallow marine environment. Right? So now the boundaries between beds are called contacts, which can be depositional, erosional, or structural. So now bedding is labeled as, so you see here thickness. So less than 1 centimeters. Bedding is less than 1 centimeter. It's called lamina. So bedding is 10 centimeters to 1 meter. It's called moderate beds. Okay. And bedding is greater than 1 meter. So it is thick beds. And massive. Massive means no beds apparent over several meters of exposure. Okay. And also layering. Layering is the linear deposition of constituent sediments like small fragments of parent material. So if the individual layer are less than 1 centimeter thickness, they are called lamination, right? So lamination, one you see a planar structure fine with 1 centimeters or less in thickness. Okay. So they are called lamination. So lamination is a characteristic structure of fine grained sedimentary rock like clays and shales, right? So these individual layers are called lamina. Okay, Lamina, lamina. NAE, sorry, LAMAMINAE, lamina. So they may be parallel or non-parallel, right? So this continuous or discontinuous and curved, either wavy or planar. These are wavy or planar. So it can be formed by alteration of light and dark layers. The changes can occur in grain size, clay percentage, and microfossil and also minerals. So the lamination can occur as parallel structures or in different sets that make an angle with each other. And determination of the lamination is easy on fresh surface but difficult when the rock is massive or it has been intensely sheared, right? And also stratum is there. Stratum means it is an umbrella tone which is used to cover both bed and this lamina, bed and lamina. So stacking up process of strata one over another, that is called stratification. Okay. So you see this is the lamination. Okay. So bedding and lamination define stratification, right? Bedding and lamination that defines stratification. Bedding is thicker than 1 centimeter, whereas lamination is thinner than 1 centimeters, right? So bedding is composed of beds and lamination is composed of which one? Laminate. Okay. So parallel lamination is a common internal structure of beds. It relates to a process by which sediments are laid down one after another. So as to appear like one set over other set. So after often terms bedding and stratification and layering, those are used interchangeably. So most commonly observed sedimentary structures is stratification, right? So now you see this is the scale of stratification of thickness. Okay, you see. So greater than 100, very thickly bedded, and 30 to 100, thickly bedded, and 10 to 30, moderately bedded, and 3 to 10, thinly bedded, and 1 to 3 very thinly breaded, and zero point 0.3 to 1 thickly laminated. Okay, these are the thickly laminated, and less than zero point 0.3 thinly laminated. So this is the scale of stratification thickness. You see this is the real picture. Okay, so this is the bedding plane and horizontal beds and inclined beds. Okay. Now we are going to cross bedding. So cross bedding is, so it consists of sets of bedded material deposited by which one? Wind or water, and inclined at angles even up to 35 degrees, right? 35 degrees from the horizontal, okay? Horizontal. And crossed beds usually show truncated top, right? Truncated top and asymptotic asymptotic bottom beds, assuming some horizontally. So it is formed due to change in the velocity or direction of flow of streams, right? Flow of streams. So you see, these are the nearly horizontal units that internally composed of inclined layers, right? Inclined layers. And also these are, it is formed on tilted surface during deposition by crossing a bed to another one. So the set height is generally greater than how much? 6 centimeters. And the individual cross beds are millimeters to 1 centimeters or more in thickness. Right? So most of the cross bedding is indicated to deltas and dunes and current deposition, and the direction of the motion of the cross beds, it gives the paleo current directions. So these are the some of the cross bedding or current bedding. Current, it means cross stratification is also referred as current bedding or false bedding, right? So these cross beddings consist of inclined dipping bed, right? Inclined dipping. bedding. And bounded by the sub-horizontal surfaces, and each of these units is termed as a set, right? It's called set, S-E-T, set. So a group of similar sets are termed as cosets, right? C-O-S-E-S-E-T-S, cosets. So three sets of beds, um, that is top sets, bottom sets, and four sets, right? So uh, these three bits, right? So often the top and bottom set are parallel. Top and bottom set. You see here. Top and bottom set are parallel, and the four set meet the top set at high angle. You see here this one, high angle. So when the top and bottom beds show convergence at a point, it is said to be wedge cross. It's called wedge cross stratification. So in tabular cross bedding, the top and bottom sets are more or less parallel. But when the top and bottom sets tend to meet, they form lensoid cross bedding. So the truncated top of the cross bedding indicate upside, and asymptotic bottom is on the downside or basal side. Okay, this one. Now you see types of cross beddings. There are two types. So first one is tabular cross bedding and rough cross bedding. So tabular cross bedding, it having planar bonding surfaces, planar, okay? And rough cross beddings having curved. These are planars and these are curved bonding surfaces. And what are the use of these beddings? The orientation of the cross beds indicates the paleocurrent directions, and also the style and size of cross bedding used to estimate current velocity, right? Current velocity. You see here this picture, planar or tabular and tough cross beds. Okay, so these are the tough cross beds. This is called set and this is called coset. And here also this is called set and this is also coset. So this is the real pictures of this planar cross beddings and rough cross beddings. Okay. Now we are going to next one is graded bedding. So they show progressive variation of grain size from coarser at the bottom to fine towards the top of a bed in a gradational manner, that is the towards the top of bed, right? So each layer of sediment with a graded bed contains a variety of grains, both coarse and fine grain. But the mean size of the grains gradually decreases upward. A graded bed comprises one set of coarse to fine beds. Normally, it ranging from a few centimeters to several meters thickness it have. So the total thickness is up to many hundreds of meters. They may be deposited in deep ocean waters by turbidity currents flowing along the ocean bottom. So the larger, heavier clasts settle down first, following by the smaller, lighter clasts, producing vertically sorted graded beds with large clast on the bottom and finer clast on top, right? So the gradational finding upward sequences are common features in standing water suspension deposits where seasonal variations are effective. So now it is bedding in which the particles are sorted according to density, size, shape, water, good medium, right? And these particles in water settle at different rates depending on size, density, shape. and it forming graded bed with layers of coarse material deposited first and fine grain deposited after. Okay. So these layers can range from a few millimeters or centimeters to several meters. Okay. So grading can occur in beds of almost any thickness. So now this graded bedding types, there are two types is there. First one is normal grading and second one is reversely graded. So normal grading means if the grain size, particle size decreases upward. So that is called normal grading. You, you see this one. Fine grains going upward. It's called normal grading. And reversely graded means these are graded rare and often related to pyroclastic flows and mass wasted grain flows and density segregation of fine grain, heavy minerals from coarse grained light minerals in beach environment. Right? So, see here normal grading is if the particle size decrease upward. Decrease upward. You see here, so these are the small particles and these are the fine particles, right? So these are going to upward. So in reversely graded, you see here when the particle size increased upward, right? So that is decreased and this is increased. Increased. You see here opposite, this one. Okay. Going to downward. Okay. So this is called normal grading and reversely graded. So you see some pictures, real pictures. And next one is sand dunes. Sand dunes means these are ridges or hills of sand built by either wind or water flow, different shapes, sizes, and regions. Those are regions means coastal and lakeshore plains and deserts, right? So the origin of sand dunes is very complex, but there are three essential prerequisites. So those are first one is an abundant supply of loose sand in a region, and next one is a wind energy source sufficient to move the sand grains, and third one is a topography whereby the sand particles lose their momentum and settle out. Okay, these are the three essential prerequisites. So the direction and velocity of winds in addition to the local supply of sand, it results in a variety of dune shapes and sizes. You see some of the types of sand dunes here. So you see some pictures. These are called Barkan dunes. This shape. Okay, this shape. These are star dunes. Okay, star dunes like this. Okay, it's showing like star and transverse. You see here this one. Okay, like transverse and parabolic dunes. It means it's opposition of Barkan dunes, right? This one. And next, longitudinal. Longitudinal means like this. Okay, wavy, light wavy dunes. Okay, these are the some types of sand dunes. And next one is ripple marks. A ripple mark is a wavy structure. It characterized by a crest and a trough, right? Crest and trough. So in other words, they are very small dune-like features of sand, right? Sand or silt. Silt whose long dimension is at right angles to the direction of current movement. So these crests generally run parallel to each other. So which may be sharp or rounded or flattened. So they form low, narrow ridges, mostly how much 1 to, right? 1 to 2 centimeters. 1 to 2 centimeters separated by wider troughs. So these ripple marks generally result from interplay of wind and wave action during the process of deposition of sediments in shallow waters. So there are various terms like ripple height, ripple length, and lee side, star side, summit point, toe point, and brink point, trough point, slip face, bottom set, and ripple index, and also symmetry index. So these are used to describe in ripple methodology, right? So, and steeper phase of a ripple dipping in the down current direction is called the lee phase, right? Lee, L-E-E, lee phase. Sorry. Mhm. Okay. And gently sloping face dipping in the opposition direction, and that is called stars. Okay, stoss, stars. And the crest of the ripple is called summit point, summit, summit point. Okay, and vertical height of the crest above the base is the height of height of the ripple. Okay, that is called height of the ripple. And horizontal distance from one crest to next crest, that is the length or wavelength of the, it's called wavelength of the ripple. So the ripple index is given by the ratio of wavelength to wave height. So erosion of sediments from the star's face of the ripple and deposition of the sediments on the lee side, it causes the ripple to migrate downstream. As the pressure increases in the downflow direction, the layer of fluid at the bottom is forced upstream by a process called, which, what is that? Flow, right? Flow separation. Flow separation. So this flow separation takes place at the crest end and eddy develops within the trough. So the point where flow separation is initiated is called the, what is that? Brink, B-R-I-N-K, brink point. Okay. So this point of flow reattachment is the toe point of the these ripples. Okay. You see, this is the symmetrical, you see. So types of ripple marks, there are two types. First one is symmetrical ripple mark. Second one is asymmetrical, right? Symmetrical, asymmetrical. So symmetrical means they are formed by two-way, right? Two-way current, and it is not inclined in the direction of the wave, often found on beaches, right? So that is called symmetrical ripple marks. And asymmetrical means there are these are created by one-way current by the river or wind. So it is inclined in the direction of current, and it can develop in almost any environment, that is river, delta, shoreline, offshore, shelf, and deep seas. So these are the symmetrical and asymmetrical. Okay, symmetrical ripple marks and asymmetrical ripple marks. These are the pictures. Okay, you see. So this current ripple marks. So the ripple marks are common in both modern sands and ancient sandstones. There are two common types of ripple marks here. So that is symmetric and asymmetric, right? Also called current ripple marks or wave formed ripple marks. Okay. So it means current ripple marks are asymmetrical in nature, right? So it having, what is that? Parallel, right? Parallel, long, more or less equidistant ridges trending in straight lines. You see here, right? Straight lines at right angles to the direction of flow leeward side. Okay. These current ripples are the commonest bed forms encountered within the lower flow unidirectional region. Here, the both the crest and troughs are rounded here, right? Now, waveforms, ripple marks, also known as symmetrical ripple marks, right? So it form when when the water moves back and forth, such as tidal action. So the symmetrical ripple marks can give an indication of bed's deposition and pointing ripple crest upwards. So these are shallow water features, and these are indicative of a stagnant body of water frequently agitated by waves. Okay. So now you see these are some of the ripple marks, asymmetrical and symmetrical ripple marks. Okay. Real pictures. So this is the schematic cross section of ripple marks. You see. Now we are going to go raindrop imprints, right? So these are irregular, right? Irregular or small um, crater shaped depressions with slightly raised edges seen on fine grained, remember, fine grained dried soft sediment surfaces. Okay. So these raindrops are falling on the surface of fine grained compacted clay often makes crater like depressions. So thus they are shallow depressions surrounded by low ridges, right? It formed by the impact of hailstones, etc. So these may get dried up, and subsequently it preserved under another layer of mud above them. So these raindrop imprint cause very minor disturbance to the bed surface, but leave a very distinctive pattern. So these raindrops are good indicators of subaerial exposure, but those are not exclusive to arid climates, though they may have a higher preservation potential in such conditions, right? So, and these are with few millimeters thickness and less than 1 centimeters in diameter, and it is usually occurs through some form of flood catastrophe. Flood catastrophe, right? So the imprint results of the impact of rain on soft sediment surfaces like mud or sand, right? So which is rapidly hardened into rock with the still intact. So this is also known as trace fossils, right? Mm, and also they can be preserved as widely scattered impressions or in close proximity to one another on the sediment surfaces. Now you see these are the real pictures of the raindrop imprints. Okay, these are the real pictures. You see this one. So you see, observe this size. Okay, size also here small. This is the small size. This is the high. Okay. That's why you see here the thickness, how much? The few millimeters thickness and less than 1 centimeters in diameter. Okay. Now, mud cracks. Mud cracks means it formed muddy sediment, right? Muddy sediments when dries and contracts occurs in clay soils as a result of a reduction in water content, and the top layer tries to shrink while the material below stays the same size. So these cracks may later on filled by which one? Sediment and form cats. So when the mud cracks preserved on the top of a bed, the cracks look as they were at the time of formation or as cats on the base of the overlying beds. So now you see these are the pictures, mud cracks. Okay, see these pictures. Okay, this one. This is the real picture, and also we have soul structure is also there. Soul structure means flute marks, right? Flute marks means like this one or this one. Okay. So it means those structures are preserved on the base of, you see here, base of bed, which is sharply differentiated lithologically from the bed below. So they usually occurred at the interface of two different lithologies. So that is soul marks are found mostly common in turbidite deposits. They also include flute cast, which are grooves eroded by turbulent flow and later filled with coarse sediments. And these flutes are enlarged depressions that form on the bottom of the body water as the current eroded or current erodes. So they occur in a variety of shapes from narrow and elongated to abrupt transverse scores and either in isolated marks or in indistinct clusters. So these flutes are heel shaped, right? Heel shaped. You see this one heel shaped halos and scoured into mud bottoms. So each this halo is generally in filled by which one? Sand, right? Sand and attached with the overlying bed. The rounded part of this flute is at the top of current end. Okay, so these are the So flute marks are soul structures. Okay. So now up to here, this structures is over. Just wait. I will upload another one. Now you see here. So unconformity. Unconformity means so unconformity means the surface of erosion or not deposition occurring within the sequence of rocks, right? Sequence of rock is called as unconformity. Okay. So you see here an unconformity is a surface of erosion or not deposition that separate younger strata from older ones. It could be regional or local indicator to long or short time, right? So that is called unconformity. So it is one of the most common geological feature found in rocks or in succession. So it is different than all other geological structures. That is fold, joints, faults, right? So these unconformities are resulted due to tectonic activity, right? Tectonic activity in form of uplift or subsidence of land. So it is referred to a period of non-deposition, right? Non-deposition. So unconformity means that is gaps in rock layers, right? Gaps in rock layers. So it form when layers of rock are removed by erosion. So the farm when a period of time passes without any new deposition to produce new layers of rock. So now different types of rocks involved in unconformity, that is sedimentary rocks. Suppose sedimentary rocks are both above and below the unconformity, right? And volcanic rocks are also above sedimentary rocks below. And volcanic rocks above and below, and sedimentary rocks above plutonic rocks and below, and also some volcanic rocks above and plutonic below the rocks, right? And sedimentary rocks above and volcanic rocks are below, right? So now you see the contact between two different units is known as the surface of unconformity or plane of unconformity, which is represent a considerable length of time. So these unconformity is there are three types, right? So first one is parallel unconformity, and next one is angular unconformity, and last one is non-conformity. So, and also disconformity is also there, right? Just wait. You see here, Types of unconformity, that is angular unconformity and disconformity, and third one is non-conformity, and fourth one is local unconformity, and fifth one is regional unconformity. So this is the very important topic. They're giving in your examination types of unconformity. Okay, so like this. So first one is angular unconformity. Wait 1 second. Okay, right. Angular unconformity, it means it forms this angular unconformity, it is a surface of erosion, right? It is a surface of erosion that separates strata which are not parallel, right? So the two groups of strata shows differences in dip or in both strike and dip. So the older strata are usually tilted or folded and subsequently eroded before the overlying strata were deposited. So now the younger strata, like you see this, the younger strata are essentially parallel to the unconformity, right? Parallel to the unconformity. So some angular unconformities represent many millions of years of geological time. So angular unconformity forms when rock deposited in horizontal layers is folded or tilted and then eroded. And also when erosion stops, a new horizontal layer is deposited here. You see here on the top of the tilted layer. Okay. So when the bedding planes of the older rock layers, those are not parallel to those of the younger rock layers deposited above them. Here, you see here, here. An angular unconformity scheme. Okay. So this is the real picture you see here. Okay. So this is the another layer. Okay. And second one is disconformity. Disconformity means layers of sediments are uplifted, right? So without folding or tilting and or eroded. So in disconformity, the strata on opposite sides, right? Opposite sides of the unconformity are parallel. So this disconformity covers a large area and represents a considerable interval of time. A depositional break of less magnitude than a disconformity, that is called diasm, right? Sorry, diastems. So this diastem or the stems are the smallest breaks recognizable in the deposition of a sedimentary series, right? So the layers on either side of the you see here, boundary are nearly horizontal, right? Nearly horizontal. So although the rock layer look as if they were deposited continuously, a large time gap exists where the this upper and lower layer meets. So this gap is called disconformity. Okay. Now we are going to local unconformity. So the local unconformity is a disconformity. It is nothing but disconformity. But as this name implies, it is distinctly local in extent. So the time involved is very short. And during the deposition of continental sediments, such as gravels and sands and also clays, the streams move back and forth across the basin of sedimentation. So during the flood time, these streams are scour out channels which may be many feet wide and deep. As the flood recedes, the channels filled up again with sediments, right? So it is similar to disconformities, right? But as the name implies, it distinctly which one local in extent. The time involved is very short period. In the deposition of continental sediments such as gravel, sands, and clays, the streams may wander back and forth across the basin of deposition. Right? So that is called local unconformity. Now we are going to another one. Non-conformities. Non-conformities means a non-conformity is an unconformity, but that separates younger sedimentary or volcanic rocks from underlying older crystalline rocks. Older crystalline rocks means metamorphic or intrusive igneous rocks, both, right? So the great unconformity is known as the Eparchian unconformity. Eparchian, Eparcha, Eparchian unconformity. So it is a non-conformity. So this unconformity separates the Archean crystalline rocks from the overlying younger sedimentary rocks. So another but a less common type of unconformity is also recognized. A surface of erosion may sometime it may be covered by a thick and residual soil that grades into the underlying bedrocks. So now the younger sediments deposited above this erosion surface may not be visible. So such a contact is called blended unconformity, right? So these are the depositional surface separating younger sedimentary or volcanic rocks from underlying older crystalline rocks, right? So these rocks above non-conformity may contain fragments of older igneous rocks, either as readily recognizable pebbles and boulders or as small fragments recognized only under the microscope, right? Next one is regional unconformity. So that is when a unconformity would be traceable over a large area. It extended for hundreds of kilometers. Such type are called regional unconformity, right? So the main type of regional unconformity recognized in India, those are Eparchian unconformity, post-Vindian unconformity, and Paleozoic unconformity. So the Eparchian unconformity separate Archean group and Purana group in peninsular India. And post-Vindhyans are seen in peninsular and extra-peninsular in India. And Paleozoic separates Darwar group from Aryan group and it's traceable in extra-peninsular India. So these are the unconformities, right? So while these criteria may indicate an unconformity, it is to be confirmed through structural mapping, subsurface exploration, and biostratigraphic studies, right? So these unconformities can be recognized in many ways, but care should be taken to see that angular unconformities, those are not confused with fault contacts and non-conformities with igneous contacts. So disconformities may be completely overlooked because they lack geometric expression, the rocks above and below the unconformity being parallel, right? So now outcrop characteristics of this unconformity, it observed of an unconformity in a single outcrop is the most satisfactory method of recognizing that. So the outcrop may be small and only a few feet across, and it may be a natural exposure such as the side of a valley or a canyon, or it may be an artificial opening such as a quarry or tunnels, right? And this angular unconformity is easily mm, easy to recognize because the beds are opposite sides. You see here, sides are not parallel, right? Beds are opposite sides are not parallel. The strata above any unconformity commonly show a basal conglomerate normally composed of clads of rock below the unconformity. So, however, the basal conglomerates are not necessarily present along angular unconformities. And also faults and dikes will be found truncated at the unconformity, right? And disconformity, mm, these are, it can be recognized by sharp contrast in color between the rocks above and below the contact. In the wavy nature of the contact and thin conglomerate present above the contact. So it is necessary to study the regional relations in order to distinguish between a disconformity and also local unconformity. So the non-conformities in order to distinguish between a disconformity and a local unconformity. So the non-conformities are to be distinguished from intrusive igneous contacts. In non-conformities, the rocks above usually contain fragments of the older igneous rock, right? In some cases, the plutonic rocks may seem to grade into the overlying strata through arkose rock, right? Arkose, which may be many feet thickness, right? So in the case of an intrusive contact, not only metamorphic effects are seen in the adjacent strata along the contact, but the dikes may penetrate the adjacent rocks, right? So these are the outcrop characteristics of these conformities. So these are the today lecture. So unconformities, these are very, very important things, unconformities. Okay, right? Now in next class, I'm telling giants, right? Giants, what are the giants and types? Okay. Okay, now I'm closing this. Right. So I can start from here. Okay, now time is up. I'm closing the session.